Hey guys, we're back at it again. Sorry, my computer's about to die in the. There it goes. All right, sorry. Okay, so we are back at it again, and we are going to go over what are called logarithms. So we're going to go over what's called logarithms. Let me change the thickness on this thing here. Okay, so logarithms. So we're going to kind of compare the graphs of two things. So let's say we have like y equal 2 to the x power, like that. So y equals 2 to the x. So this one is here. And we have two main points. We have one that is 0 and 1. And then the other one, if I plug in 1, I get 2. If I plug in 1, I get 2. And if we kind of follow that, we end up getting a graph that looks something like this. Okay? So this point here is if I plug in 1, I get 2. So if I plug in 1 right here, I get an answer of 2, because 2 to the first power is 2. So if you notice, every time I plug in 1, I get the base out. So this is 1 and 2. So these are called exponential functions. And these are called exponential functions. And so when we're dealing with exponential functions, they have this pattern that looks like this that you see, and then they never cross the x-axis. And so this is called the asymptote. So we have an asymptote at 0. We're going to call that at y equals 0. We have a main point that always is 0 and 1. We have a main point that is always 1 and its base, which is 2 here. Okay, so then if we go to logarithms, which is this piece right here, if we go to the logarithms, the logarithm is its inverse. So it's the inverse. So if we talk about the inverses, we switch the x and the y. So if we do y equals log of 2 to the x here, if we do y equals log of 2 to the x, this is my base right here. So that's the base. And we have this graph that we know that we switch the x and the y. So if we switch the x and the y, that means my new point here is at 1 and 0. 1 and 0. And we also know that it's at the base and 1. So my other point is at the base, which my base is equal to 2. My point is 2 and 1. So these things curve just like that. Sorry for the bad drawing, guys. And my asymptote was on the x-axis, which is y equals 0. But now it is on the y-axis. So the asymptote is on the y-axis at x equals 0. So if you kind of look at this, this one points, the exponential one points here. It goes from 0 to 1 is the main point, and it's 1 and its base. If you go to logarithms, we're looking at them here to where the asymptote is at the y-axis, and instead of 0 and 1 like we have here, we have its inverse, and I'll rewrite that so you can see it, which is 1 and 0, right? It's 1 and 0, and then it's base and 1. Okay, it's base and 1. It's the base and 1. And again, I know the handwriting isn't the greatest, but if you saw what I was writing on right now, you'd know that it's not very easy. So we have logarithms that are inverses of the exponential. They have the same curve. And then the differences are that the asymptotes are on different axes, and our main point 0 and 1 and 1 and 2 are inverses of each other. So we get 2 and 1 on 1 and 0 on the logarithm. So now if we take that same idea and we extend it, there's a little bit different exponential function. And we call that y equals e to the x. Okay? Now, e is a constant number, so it means y equals 2.77 to the x power. Okay? That's what e equals. So e is 2.77. And so if we take that same idea of exponential, we know from our last little conversation that our asymptote is right here at 0. We know our main point goes through 0 and 1. And then we know that if I plug in 1, I get out the base, which is 2.77. So this is 1 and 2.77. Or another way to write that is 1 and the number e. Okay? So now we just follow our curve, and then we've got our curve that way. Now, when we have e to the x, we have its inverse, which is basically y is equal to the natural log of x, which is actually can be written as log, so a logarithm with the base e to the x power. These two are the same thing. Okay, those are the same thing. You won't really ever see it written like this. It'll be written like this, the natural log. So when we look at this thing, when it comes to its graph, is we have our graph here. And remember, this is the inverse. So as we deal with inverses, we remember we switch the x and the y's. So if we go back here, my asymptote that we have, it switches to this. My 0 and 1 will switch to 1 and 0. And then my base of 1, my other main point of 1 and the base will become the base and 1. So it's 2.77 and 1. And then my curve goes a little different, just like that. All right? So as we look at these things, the biggest thing I want you guys to understand is that we have two main points on this one, 0 and 1, and 1 in the base. And then on this one, we have 1 and 0, and then the base and 1. Okay? And don't forget, E is the same as 2.77. And so when you work on your homework tonight, you're just going to be comparing what's the differences and similarities between exponential and logarithms, and then what's the difference between e to the x and the natural log of x. So this will give you the information, and then we'll gradually work with this in the next couple of days, guys. All right? Other than that, make sure you do your notes ahead of time, and we will talk to you soon.